Machine learning is teaching a computer, a machine, to make decisions.
So machine learning is basically training computers to do tasks that people can't or don't want to do.
In one day, we collect something like 85 terabytes of data. For that one day's worth of collection, you'd probably be at it for about 80 years. And so machine learning is really the only way that we have of being able to deal with that data deluge.
Machine learning has been around for a while. You don't have to teach a machine what to look for. You just give it examples and it learns itself.
Machine learning algorithms can help humans take advantage of this data and derive new insights that might not otherwise be possible.
We can ask questions about everywhere on the globe. We can see where the things are changing the most quickly. We can identify patterns that have never before been possible. And we can take existing workflows and questions about the planet and apply them at a much larger scale, much more efficiently.
SpaceNet was the first of its kind to create an open data set for geospatial and machine learning consisting of satellite imagery, building footprints, and roads that could be applied with algorithms for automated mapping.
GBDX is our cloud analytics platform designed to extract meaningful insights from satellite imagery for a multiplicity of use cases in industry, government, humanitarian and global development organizations, and academia.
By using satellite imagery and machine learning, we're able to detect where populations are even in the most rural parts of the world. For example, in Tanzania, where the distribution of polio vaccines depends on where people are located.
So we're working with Gates in Tanzania to support local census activities, to map where populations are growing and changing, and to understand where development resources would be most impactful, like aid or investment for local populations.
Australia is an incredibly large continent, developed continent, but to this date, nobody has actually known with any certainty how many structures reside within the country. Using satellite imagery and machine learning, we were able to detect all the structures and map for each parcel. Where's the building? What's the vegetation like on the property? What's the roof material made of? What's the height of the building? And a whole host of other features. This aids insurance companies. This aids the financial industry. This aids emergency responders.
When we think about innovation and when we have major steps forward in technology, whether it's aviation or the personal computer, it feels like we're at a place today where machine learning and artificial intelligence are helping us do things that might not otherwise be possible.
One of our focus areas for where we're going in AI and machine learning for in-space robotics is operation farther and farther away from Earth. We've had robot arms on the space station and the space shuttle. We've had robot arms on a number of Mars rovers. As we get further away from Earth, we're less able to communicate in real time with those robots, so they need more smarts on the robot to be able to perform more advanced tasks because there's not a human who's able to be in the loop. And so that's placing the autonomous operation in a robot in space, similar to an autonomous operation of a car driving on the road, but the space environment's very different. You don't have to worry about pedestrians, but you do have to worry about bumping into other satellites. So in addition to what we're doing in robotics, we're extremely well equipped to work on another domain, which is the extraction of geospatial information from satellite imagery. Why is Maxar uniquely equipped? Well, Willie Sutton, who was a famous bank robber, was asked why do you rob banks? And he said, well, that's where the money is. In AI and machine learning, the critical thing is where's the data? Because you need data to train those machine learning models. You need lots and lots of data. And we have the data, whether it is decades of experience in in-space robotics or north of 100 petabytes of electro-optical and radar data, we have the data that can be used to train those machine learning models. The second thing we have is domain expertise. We're talking about extracting information from satellite imagery or controlling robots that are far away from Earth. And because of our customer relationships, we have that domain expertise in a way that a general practitioner would not. And the third is, of course, our people. Our people are incredibly smart, they're motivated, they're willing to leverage the tremendous amount of work that's gone on elsewhere in the industry and build on that by standing on the shoulders of the many thousands or tens of thousands of people who are working in this domain moving us beyond.
As far as leading the charge on machine learning, deep learning, artificial intelligence, Maxar is perfectly suited because that's what we specialize in.
Maxar is developing amazing technologies in-house, but is also encouraging an entire industry to thrive. From the SpaceNet initiative, where we're making training sets available for people to build their own machine learning algorithms, to the GBDX ecosystem, where we're encouraging people to plug in their own models against our corpus of 100 petabytes of imagery. Maxar is leading a revolution, not just for its own customers or for its own employees, but for the industry as a whole.